Okay, so the transformation of your parent function, exponential function. So there are four types of transformation. So when you say plus 1, this graph moves 1 unit up. If you have y equal to 2 power x minus 1, it will move 1 unit down. So the graph will move 1 unit down. Now, when you have y equal to 2 power x plus 1, that means graph will move horizontally 1 unit left. 1 unit left. And when you have y equal to 2 power x minus 1, 1 unit horizontally right. So this is what the graph will move when you apply this four transformation. So this is up and down, left and right. Now there are other types of transformation, that is vertical stretch and horizontal stretch and compression. So when you have 2 power x, when you multiply by here say number 5, this is vertically stretched by 5. When you have a 1 upon 3 into 2 power x, this is vertically compressed by 1 upon 3. Same way, you have y equal to 2 power 2x. This is horizontally compressed by 1/2. And when you have a y equal to 2 power x upon 3, this is horizontally stretched by 3. So this is the transformation that you apply to exponential functions. Now you can graph the function with this type of transformation. So let's take a graph of y equal to 3 power x. Now this will be the graph of y equal to 3 power x. This is 0, 1. Now when you move your graph by 4 units to the right, that is your this graph x minus 4. So this is the d value. So d value is moving the graph left or right. If it is positive, graph goes to the right. So this one, the graph will be moving to 4 units to the right. 4 units right. And when you have a graph multiplied by 2, it is vertically stretched by 2. So this I will put into the bracket. So this is vertical stretch of 2. And if you have a minus here, the graph will reflect it on x-axis. So when you have a graph reflected on x-axis, it will go like this. This is the reflection. And when you have a vertically stretched by 2, the graph will go like this. And when it is moved 4 units to the right, the graph will go like this. So this is your point that was here, that is moved to the right. So this is the transformation you applying to a parent function 3 power x. Now if you have function, parent function like 4 power x, what are the transformation applied to this function? You have to find out, like 4 power minus 2x minus 4 plus 3. So Whenever you want to find out the exact transformation, you remove whatever is the coefficient of x. You take out this common. So now you have x plus 2 and plus 3. So this tells you that your graph is moved 3 units vertically up. This tells you that the graph is moved 2 units horizontally left, and this is your horizontal compression by 1/2, and this is the reflection on y-axis. When this is negative, that is the reflection on y-axis. So you can draw the graph of this. This is 4 power x. This is still 0, 1, and when your graph is reflected on y-axis, it will go like this. So the graph will go like this. And when the graph is moved 3 units up, it will go like this. Sorry. So this will be your graph moved 3 units up. Also the vertical horizontal compression included. So this is not the clear graph, but you can use the Desmos graphing calculator. And you can draw these graphs. Now, next thing is compare and contrast the function defined by this. So you have a function called fx equal to 9 power x, and you have a function called gx equal to 3 power 2x. So function 9 power x, you can write as 9 as 3 power 2 x, and 3 power 2 power x is 3 power 2 into x. So this is same as gx. So sometimes the function look different, but it is same. So both function are same. You can graph them also. And you can find out. Now the next question is connecting the verbal and algebraic description of the transformation. So you are given a verbal description of the transformation applied to a exponential function, and you have to write down the equation of the exponential function. So this is your function 2 power x is your parent function. When you apply the transformation, this is your vertical stretch, compression and reflection, and this is your horizontal stretch, compression and reflection. This is your horizontal left or right movement. Plus C is your vertical up and down movement. Now, in your wording, they say that an exponential function with base 2. So this is your exponential function with base 2 is vertically stretched by 1.5. So that means this can be written as 1.5 times 2 power x. Now, you cannot write equal to, so I will change this with the arrows. So this is now vertically stretched by 1.5 and reflected in the y-axis. So when they say reflected on the y-axis, that means 1.5 into 2 power minus x. This is the reflection on the y-axis. And it is moved 2 unit up. So this will be move like 2 unit up. So plus 2. So this is the equation when you are given the transformation in verbal form.